Hey, what's up, guys? We're back with day 53, related rates. I just have one quick problem here that I think is pretty interesting. We'll look at some of those book problems that you maybe didn't finish today. Don't worry, we can finish them tomorrow in class. No problem. So here's what we have. A 6-foot tall person is walking away from a 20-foot light pole at night. The person is walking at a rate of 5 feet per second. What is the rate of change of the length of the person's shadow? Okay, so right away this seems like there's not enough information. Okay, but let's take a look and see if we can figure out what's going on here. It's going to help us to draw a picture here. Okay. So here is, we know that the light pole is here, and we know that's 20 feet tall. Obviously, the light pole is not changing in its height or anything. So we can just write in the number. We don't need a variable for it. Here's the ground. Okay, and here we have a 6-foot tall person. Okay. And we know that this person, it says, is walking away from the light pole. Okay. Down on the ground, it would be the person's shadow, right? I'll use a different color to show the shadow. The shadow then, if this is the light pole, right? The light is going to shine down, hit the person's head, and land down here. So down here will be the shadow. Okay. Now we know how fast the person is walking. The question is, how is that shadow changing? Okay, that's the question. What is the length of change? What is the rate of change of the shadow? Okay, a couple of things we don't know. It never says how far away the person is from the light pole. Okay, so we don't know that, and I don't even know if we're going to ever be able to figure that out. Okay? Hopefully it doesn't matter. What I need to do here is I need to choose some variables for what's going on. Okay? I know that the person is walking at a rate of change of 5 feet per second. Right? So the distance between the person and the pole, I don't know what that distance is, but I know that that distance is changing at a rate of 5. It's getting bigger, so it should end up being a positive 5. Right? So I'm just going to name the distance between the light pole and the person. I'm going to call that x. Okay, they never assigned that a variable. This problem didn't have a variable assigned, so I'm just going to choose x. What I know right off the bat then is I know that dx dt equals 5. It's got to be positive because the person's walking away from the pole. If they were walking towards the pole, and then at 5, then it would be negative 5. I also am going to need to name the shadow's length. Once again, I don't know what my shadow length is right now, but I need to know how that shadow is changing. So I'm going to call the shadow, which starts here and finishes out here, I'm going to call that distance S for shadow. And I'm going to try my best to make my S's not look like 5s. Okay. So what I need is ds dt. So what the heck do I do? Okay, well, channel your inner geometry student, right? I'm actually working on this right now with my 9th and 10th grade geometry classes. We've seen problems with these shadow things. We saw these in geometry because we need to write an equation. Now your first guess might be, oh, let's use the Pythagorean theorem, okay? Because these would be right triangles, but we don't have any information on 2 parts of the sides, right? We don't know the bases or the hypotenuses, so it's not going to work very well because there's just too many unknowns. But what we can use is similar triangles. Okay, similar triangles is the key to this problem. Okay, so the two triangles that are similar, I'll highlight one in yellow. This triangle, so the yellow triangle has to be similar to whatever the heck this color triangle is. And when we have similar triangles, then what we have is proportional sides. So we're going to write a proportion for our sides here based on these similar triangles. Okay? So what I want to do is I want to match up the corresponding sides of the triangles to write my equation. So here's what my equation is going to look like. I remember the first time I saw this problem when I was in high school, I stared at it for so long, and I couldn't figure it out. I had to talk to my teacher. Okay? But take a look now. And then once I saw it, this ends up actually being a pretty easy problem. But the hard part is writing this equation. So here comes my equation. I'm just going to set up the proportions of my right triangles. So what I have here is, I'm going to start with the big triangle, 20. 20 over the corresponding side of the little triangle, which that corresponding side would be 6, right? 20 and the 6 correspond. So 20 over 6 has to equal the base of the yellow triangle. Now the way this is labeled, that's not one variable. That's two variables added together, right? This distance right here is the distance x plus s. Okay? Over the base of the little triangle, which is just s. So that's the equation that I can get. Now you may say, oh, this looks like an awful thing to derive because we are going to have to do a quotient rule, and it's just going to get ugly and messy. Okay? But it's really not that bad, because watch what we can do. If you were to solve this, right, if you knew numbers, your method for solving proportions would be to cross multiply. So let's do that and see what happens. Here we get 20s equals 6x plus 6s. Now that already looks way better. I don't have any quotients in there, right? And in fact, I can simplify this equation one more time and just combine some like terms here. I'm just going to minus 6s from both sides, and I'll get 14s equals 6x. So I get a very simple equation that comes out of this. And now I can do the derivative. And hopefully I don't need to know x or s to solve this. And because this is linear here, I know that the s is going to go away when I do the derivative, and the x is going to go away. So I really never needed to know x or s to solve this problem. The derivative of 14s would simply be 14 when I tack on ds dt. And that has to equal the derivative of 6x, which is simply 6. And then I multiply by dx dt. Now, the only thing I know in this problem, other than the original heights of the light pole, or the heights of the light pole and the person, is dx dt is 5. So I get 14 ds dt equals 6 times dx dt, which is 5. So I get 14 ds dt equals 30. So ds dt, the rate of change of the shadow, would be 30 over 14, which reduces to, what, 15 over 7 feet per second. And we just took a really seemingly difficult problem and turned it into a very easy one. But we had to use similar triangles. We'll look at some more problems tomorrow that involve similar triangles. That will also be kind of a challenge, but really fun. All right, guys, that's it for tonight. I'll see you guys tomorrow. Again, if you have some of that homework from today unfinished, go ahead and try it tonight, but we'll have some time to talk about it tomorrow in class as well. Talk to you guys later. 2 trains. Bye.